All right, thanks for tuning in. Let's go ahead and start up with this warm-up to get us ready to work with systems of inequalities. So if we want to graph an inequality, there's really four things that we're looking for. First, we want to know if it's dotted or shaded or solid. This would be solid because it does have that line. Oops, there we go. Solid. We're looking for above or below. This is going to be above because it is greater than the line. We want the slope, and we want b. And with those four things, we can make this inequality. Go to 1, down 2 over 1, down 2 over 1, down 2 over 1, and then just continue that in the other way. Pick a solid line, and finally shade above. That's it. If you go the other way, you can still look for those four things. What's the slope and what's b? B is -3. It starts down here at -3. Y-intercept. Slope, I think we got to go up 2 and over 3. Okay, I observe that this is dotted and it's below. So when I write my equation, it's just going to be mx plus b and then I have to pick the inequality sign that is for below or less than, and dotted, which would not have that line. Okay, so those rules are there in this table for you to, for your reference. Let's go ahead and talk about systems now. So a system is a set of two or more inequalities. The solution to a system like this is a shaded region of all the x and y values that make both inequalities true. So both inequalities true is going to be some sort of overlap of these shaded regions. So you could also call that an intersection of two half planes. A half plane is, think of it this way, for this picture, when I shaded part of it yellow, I divided the whole space into two parts, yellow and not yellow. So that's a half plane. That yellow is a half plane because it's half of the xy plane. So when I have two of these inequalities on the same graph, you're going to see what this intersection turns out to be. So let's just do some practice. So introduce you to it. We want to solve for y because we can graph that the easiest. So I am going to go ahead and do that for us. So we got two lines to do. I'll do the top one first. Go down 1 over 2, down 1 over 2. So it looks like something like this. It is in fact solid. And I do want to shade above because it's greater than. So I'll just go ahead and use my colors and shade above. Okay, the other line is at +3 and it goes up to over 1. So could also continue it down here, and this one is also solid. And it shades above. So if I take red and do a little bit of shading, right, we get an orange region, and this is the solution. Every point in that orange region will make both of those inequalities true. So it's kind of neat how this happens. Typically, it'll work out like this, where you have one intersection point and you have these four regions. The orange one, the yellow one, a red one, and a blank one. And it's the orange one that's our solution. Okay? So you could do some light shading in pencil and try and draw it this way. That is one way to do this. I'm going to show you another way to do it if you didn't have a pencil and you only had maybe a pen. But these, I need to do some work on these, don't I? Because they're not solved for y. Okay. So I know you guys can work through this. One thing though, we're divided by a negative. So we got to flip the sign. So let's graph this top one first. You go to 2. We're going to go, the slope there is -0.5. Down 1/2. Oop, and I shouldn't be so quick to make it solid. It is dashed. Because it doesn't have this line underneath. And we're going to shade it below because it's less than. So rather than pulling out my colors, I want to shade it like this. With these nice even lines that are evenly spaced. Okay. And then I'm going to go in and graph the other one the best I can. It gets pretty chaotic, but I can go to -1 and, oh, hold on, I'm sorry. This was underlined. This is going to be solid. So let me just go ahead and connect those dots there. My fault. The other one, though, is going to be dotted. And it's going to go down 1/1, down 1/1, because that's the slope, down 1/1. Okay, so this goes all the way up here, and it is in fact dotted, so I'm just going to add some more dots. Okay, and then in the midst of everything, we want to try to shade. And we have a greater than sign here, so we're going to shade above. So I want to pick lines to draw that kind of complement the other diagonal lines that are different. That way we can have a good sense of where these overlap. So it is that, just so you can see it, it is this region that is our solution now, because both of the shading, both of the shaded regions overlap there. And that's what systems are about. You gotta appease everyone. All the equations have to be true. So if we do have overlap, that signifies that we have both being true. Here are some rules if you'd like to follow them. It's what I've just gone over. Sometimes people like to see the steps written out. How do you go in reverse? Well, you just gotta find those 4 key facts. So for this dotted line, I want to call it dotted. It looks like, so above or below is the question. And this picture is finalized. It just has the overlap. It doesn't have like the extra, like for example up here, it doesn't have the extra yellow and red. So it's a little bit harder to see, but I know that the shaded region is below the dotted line. It's certainly not above, so it has to be below. And it looks like B is 1, and the slope is down 3/1. So mx plus b, y, and then I want to choose below, which is less than, and a dotted, which I'm going to keep like that. There's one equation. Okay. Other one is solid. And the shaded part is above part of the line. It's got a b value of -1, and it goes up 1 over 2. Right? Up 1 over 2. mx plus b. There is our inequality. We got to pick the sign though. It is solid, so we'll see a line here. And it's above, which is greater than. That's it. Those two together form the system that would generate this picture. Okay, so there's 4 things. Let's do this one more time here, just to make sure we have it. So this is dotted. The blue is below. B is at 1, that's the y-intercept. And for slope, this looks like another even point, so down 1 over 3. Perfect. mx plus b, y, that is the answer, but of course it's below, less than. Dotted, I am not going to put a line underneath. This is strictly less than. And what that means is like, so this blue region is all of our answers, but if you had a point that was right here on this line, all right, so, and then for this other line, we see that it is horizontal. So, sorry, this one. And horizontal lines are like, this one is y equals -2. So those are flat lines. So the symbols that we're going to pick here is, it is above the line, and it is solid. So we're going to pick that, okay? So those two together form that system. Okay. Finally, let's talk a little bit about this word problem. So we need 2 inequalities from this. So it looks like we are sponsoring a concert and we have a goal of 30 grand that we want to make from this. And the way that we make that money is figuring out how many balcony seats and how many orchestra seats we can sell. Okay, so I'm going to let X be the number of balcony seats. And let Y be the number of orchestra seats. It says that the money has to be at least 30 grand. So I know that some expression that's going to calculate money has to be bigger than or equal to 30 grand. The way we get money is $20 times the number of balcony seats we get, plus $30 times the number of orchestra seats we get, right? That's just how you calculate the money, is you, the number of balcony seats, you multiply that by 20. Orchestra seats, you multiply it by 30. Add them up, you get the total amount of money that you raised. Okay. This other equation here says that the orchestra seats are limited. There's only 500. Which means that Y, the orchestra seats, can only be as large as 500. It has to be equal to that or less. Okay. So I'm going to try and solve this for Y in the best way I can. I know I have a lot of zeros showing up here, so I decided to divide by 10, and then I'm going to move and isolate the y. Okay, so I'm going to divide again. And then it's just a matter of taking these two equations and just plotting them. So the 500 line should be right here. And we are below that line. So if you want to draw a little arrow that says below, that's cool too. And then we have to plot this line. So it's the b value is 1,000. And then in general, it goes down to over 3. So instead of trying to find, I mean, the y-axis is different. So I'm just going to take these huge squares and go down 2 huge squares and over 3. And connect this with a solid line. And we have solid and we have above. So it's going to look something like this. Okay. So as I'm shading this in, you kind of notice that we do have some overlap happening. And that is this region right here. This is the solution. We shaded above here. One thing that I kind of did without telling you is I included these two equations. I'm sorry, inequalities. I'm only looking at the first quadrant, positive things, because I can't have a negative amount of seats. So my regions are also kind of bounded by the x and the y-axis, and everything's kind of cropped to the first quadrant. Okay, so any point in the orange is going to be a valid solution. Okay.